Okay. Hello ladies and gentlemen. Today we're going to be looking at how do you expand any bracket to a power that's greater than 2. And sometimes it can be really annoying. So something like this. Let's say I have x plus 1 to the power of 4. Okay, the normal way that you would do this using your algebra classes, any algebra classes you've undertaken, is just doing x plus 1 times x plus 1 times x plus 1 times x plus 1. And you know how to expand brackets this way. You can expand to get this, times this, times this, times this, times all of this. Then you have to do the same thing with this term here. Then you have to do the same thing with the next x plus 1 and the next x plus 1. It's very, very tedious and cumbersome. I'm going to teach you a little way that's using Pascal's triangle. And the only rows of Pascal's triangle that I have memorized, and I would encourage all of you to memorize, is everything up until the 6th row. And for those of you that don't know what Pascal's triangle is pretty much a series of ones that alternate like this. So you have 3 ones like this, and the number that goes beneath these two, one is the sum of these two numbers. Because the sum of these two numbers is 2, this would be like their child. We would say this is like the parent term, and the child term is the 2. And you just fill it off with a 1 and a 1. So it's a ever cascading row of 1s this way, ever cascading row of 1s this way. That's why it's a Pascal's triangle. And if we continue, I can see that 1 plus 2 is simply 3, and 2 plus 1 is simply 3, 1, 1. And if I continue this way, I can say 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and 1, 1. And I keep going until I get to 1, 5, 10, 10, 5, 1. These are the only rows of Pascal's triangles I have memorized. If they ask you to do anything more than this, you can simply construct your own Pascal's triangle. So now let's have a look at this and how on earth it relates to expanding x plus 1 to the power of 4. If I want to expand x plus 1 to the power of 4, the trick I can use is look at the row that contains the term with the number 4. In this case, I can see this row here in Pascal's triangle contains the number 4, i.e. the second number in the row. So this number is 4. That's the row I'm going to use. I can say that all the coefficients in my expansion will contain the coefficients of 1, 4, 6, 4, and 1. So in doing so, let's see how this plans out. The first thing I'm going to do is I'm going to write the coefficient for the first term. The coefficient for the first term in this case is simply 1. So 1 is my coefficient. I'm going to draw 2 brackets. Inside the first bracket goes the first term of my bracket that I want to expand. So x goes in here. And in the second bracket goes the second term I want to expand. That would be 1. The first bracket is raised to the power of the question. It's raised to the power of 4. The second bracket is raised to the power that sums these two together. It'll always be 0, so the power of the first bracket will always be 0, if you didn't understand that. So that is my first term in this expansion. Let's keep going. The second term will have a coefficient of 4, and we can draw our 2 brackets once again. And the rule is kind of simple. Okay, so x and 1, those are 2 terms. The rule goes as follows. The first bracket's exponent will keep decreasing by 1 each term. You will decrease by 1 each term. And this bracket's indice will be increasing by 1 each time. So what that means is this is currently x to the power of 4. It becomes x to the power of 3 in the next term. If this is x to the 1 to the power of 0, it becomes 1 to the power of 1 in the next term. And it follows that very nice, neat pattern. And let's keep going. The third term has a coefficient of 6. We can say x and 1. The x is to the power of 1 minus the previous one, which is 2. And the 1 is raised to the power of 1 plus the previous one, which is 2. And keep going. We have 4x to the power of something, 1 to the power of something. So the x exponent is minus 1, so it's 1. And the 1 exponent is added 1, so it's 3. And then the last one is plus the coefficient of the fifth term is 1. So 1, x to the power of 0, 1 to the power of 4. These are the terms in our expansion for this question here. So all we have to do now is simplify. We can say that 1 times x to the power of 4 times 1 to the 0 is x to the 4. We can simplify the next term by saying 4 times x cubed times 1. 1 to the power of anything will always be equal to 1, so we don't have to worry about that in this question here specifically. But we can say this is the same as plus 4x to the power of 3 plus 6x squared plus 4x plus 1. And that is how you expand this expression here using the Pascal's triangle. And I'm going to give you another one now to do on your own. I'd like for you to do x take 2 to the power of 3. Pause the video and have a go at this by yourself. Okay, that's enough time. So if you want to expand this here, all you would have to do is recognize which row on my Pascal's triangle am I trying to look at. Well, I can see that 3 is the row that I want to look at. The second term in that row must be 3. So it's this row over here. The coefficients of each of my terms would start with 1, 3, 1. 1, 3, 3, 1. So now in expanding, it should look like this. The first coefficient is 1, 2 brackets. First term is x, second term is minus 2. The first term is to the power of what is in the question, so 3, and the second term will always be to the power of 0. And it's an alternating pattern, so this bracket will be decreasing by 1 its exponent, and this exponent will be increasing by 1 each term. So the second term's coefficient is 3, x to the power of 2, negative 2 to the power of 1, plus the third term's coefficient is 3, x to the power of 1, minus 2 to the power of 2, plus fourth term's coefficient is 1, x to the power of 0, negative 2 to the power of 3. Let's keep going. So if we wanted to expand all of this out, all we would have is x cubed, and negative 2 to the power of 0 is simply equal to 1. So 1 times 1 is x cubed. Then we can say, in the next term, 3 times negative 2 to the power of 1, negative 2 to the power of 1 is just negative 2, times by the 3 is equal to negative 6, and we're left with this x squared. So it becomes negative 6x squared. Then we can say negative 2 squared is equal to 4, times by the 3 is equal to 12, and then we're left with x to the power of 1. So it's just 12x. And then we can say minus, in this case it's minus because we're doing minus 2 to the power of an odd integer. So minus 2 cubed is simply equal to 8. 8 times 1 is still 8, and x to the power of 0 is still 1. So that means it's just minus 8. That is how you expand this bracket over here. Now let's go for another question as well. Let's keep doing one more. 2x take 3 to the power of 5. This one's going to be quite a lengthy one, so I'm going to give you some time. Pause the video so you can have a go. Okay, let's have a go. So I'm not going to explain every single step with this one. If you need me to, just comment in this comment section below. I'll be sure to get to you. If not, someone else in the community can. So 2x take 3 to the power of 5. Which row do I use in Pascal's triangle? Well, it's the row which has 5 as the second term. 1, 5, 10, 10, 5, 1. So in doing so, we can have 1 as the coefficient of the first term, 2x, negative 3. The exponent of the first term is 5, and the exponent of the second term is 0, plus 5 times 2x to the power of 4, negative 3 to the power of 1. These are the two terms. 4 because it's minus 1 from the next previous term, and 5 because that's the coefficient of the second term. Plus 10 because that's the coefficient of the third term. 10 times 2x to the power of 3, negative 3 to the power of 2. In this case, we're going to say plus, I don't have enough space, so I'm going to do it down here. Plus 10 times 2x to the power of 2, negative 3 to the power of 3, plus 5, 2x to the power of 1, minus 3 to the power of 4, plus 1, 2x to the power of 0, and minus 3 to the power of 5. And now all we have to do is simplify this. So the first term, we can do 2x to the power of 5 is simply 32x to the power of 5, plus we want to expand this term here, and without the use of a calculator, it is going to be quite tricky, so definitely have your calculator on hand. To expand this, it's simply 5 times 3, so minus 15, times by 16x to the power of 4, plus 90 times 8x to the power of 3, plus minus 3 cubed is 27, minus 27, so it'd be minus 270 times by 4x squared, plus 81 times 5 is 405. So 405 times 2x plus 3 to the power of 5, I'm not sure what that is. So 3 to the power of 5 is 81 times 3, which is 243. So minus, in this case, because it's a power of odd integer, minus 243 to the power x to the power of 0 in this case, which just simply simplifies to minus 243. So now all we have to do is simplify this. This becomes 32x to the power of 5 minus 15 times 16. That is simply the same thing as if we were to expand this out. 15 times 15 is 225, plus another 15 is 240. Another way you can do that is you can say that 16 times 10 is 160. If you times it by another 5, it's just adding 80, so 240. So minus 240 x to the power of 4 plus 720 x to the power of 3 minus 27 times 4. 270 times 4 in this case, and 270 times 4 is 1080. X to the power of 2 plus 910 x minus 243. That is how you expand using Pascal's triangle.